Ensoftec has developed a series of videos for the selection and design of stormwater management facilities for land disturbance projects. This video will show you how to perform analysis for each outfall and each hydrologic unit code or HUC, and to generate reports for water quality and quantity compliance. I shall use the example from video 3 for this purpose. I open the project. You will notice that there are 3 outfalls for the HUC, VA06. Select the first outfall, Out01. I go to File, Outfall Analysis. This opens the Outfall Analysis screen. That screen has 4 sections to the right. HUC details. This section is automatically populated for the outfall. The second section is the total site area, or the contributing drainage area, or CDA, to the outfall, or the study point. I enter the areas, in acres, by type of land use: forest, or open areas, managed turf and impervious areas, and by hydrologic soil groups. You will notice that there are 2 sections here: pre-development areas and post-development areas. Pre-development areas are required only for redevelopment projects. The CDA will be either more, or the same as the sum of all the BMP site areas in the treatment train to that outfall. As in the case of BMPs, the total time of concentration TC has a minimum value of 0.10 hour, but can be computed by clicking the checkbox at the bottom left of each section. This will open the time of concentration computation worksheet. TR55 method of computing sheet flow, shallow concentrated flow and channel or pipe flow times. The third section gives the land cover summary. The program computes this information from the site data, and the results are populated in this section. The TR55 method makes runoff adjustments for ponding and swampy areas. This area is entered in acres. The fourth section gives the computations for the treatment volumes and the total pollutant loads, phosphorus and nitrogen, for both pre-development and post-development conditions at the outfall. I now click on the Perform Analysis command button. This gives the outfall analysis summary. The total phosphorus load reduction provided is compared to the phosphorus load reduction required at the outfall, and the remarked section at the bottom lets me know if it is satisfactory design. pH load reduction exceeds target, or balanced pH load reduction required. Though quality compliance is not required at each outfall, the software provides this information for each BMP and outfall to enable the designer keep track of performance. Quantity compliance is important for each outfall. The program lets us know if the outfall meets channel protection criterion, or if the outfall meets flood protection criterion based on the regulations. The regulations require that when stormwater from a development is discharged to a natural stormwater conveyance system, the maximum peak flow rate from the 1-year 24-hour storm following the land disturbing activity shall comply with the quantity compliance. The allowable post-development peak flow rate should not be greater than the product of the site improvement factor, the actual pre-development peak flow rate, and the pre-developed runoff volume divided by the post-developed runoff volume. Nor should this post-development peak flow rate be required to be less than that calculated on the basis of peak flow rate and the runoff volume for a corresponding forest area divided by the post-developed runoff volume. For flood control protection, similar energy balance equations apply for post-development conveyance discharges that currently do not experience localized flooding during the 10-year 24-hour storm event. Stormwater conveyance systems shall be analyzed for compliance with channel protection criteria, to a point where either, based on land area, the site's contributing drainage area is less than or equal to 1% of the total watershed area, or based on peak flow rate, the site's peak flow rate from the 1-year 24-hour storm is less than or equal to 1% of the existing peak flow rate from the 1-year 24-hour storm prior to the implementation of any stormwater quantity control measures. Similar exemptions apply for flood protection criteria, where the site's contributing drainage area is less than or equal to 1% of the total watershed area draining to a point of analysis in the downstream stormwater conveyance system, or, based on peak flow rate. The site's peak flow rate from the 10-year 24-hour storm event is less than or equal to 1% of the existing peak flow rate from the 10-year 24-hour storm event prior to the implementation of any stormwater quantity control measures, or the stormwater conveyance system enters a mapped floodplain, or other flood-prone area, adopted by ordinance, of any locality. Due consideration to this aspect is important while analyzing each outfall. Once I click on Perform Analysis, I save the data by going back to File, Save. I can always edit the site data by going back to File, Edit. The file, Print, will give a printout of the outfall analysis in Excel format. The printout gives more detailed computations for water quantity compliance for 1-year, 2-year, and 10-year design storms. Curve number adjustments for these storm events with the reduced runoff are calculated, and corresponding peak discharge is determined. Post-project peak discharges with and without runoff reduction as well as peak discharges for forest areas are given for calculating water quantity compliance. These steps are repeated for each outfall. VSMP permit regulations require that each hydrologic unit code should comply with water quality requirement. To verify if the designs are done to satisfy the regulations, I go to the top menu bar and click on File, HUC Summary. This opens the HUC Summary screen. You will notice that all the fields are already computed and populated for the HUC. Site areas for all the outfalls in the particular HUC are accumulated, and the pollutant load computations are completed. The summary compares the phosphorus load reduction required with the phosphorus load reduction provided. The remarks will show if the design is satisfactory or not. You will notice that for the example problem the balance phosphorus load remaining to be treated is 0.49 pounds per year. In order to meet quality compliance requirements, therefore, I have to either add a new BMP or enhance the performance of a proposed BMP. I click on Exit button at the bottom and go to the top menu bar and click on File, Exit. This puts me back to the outfall screen. I select the first outfall, Out01. I go to the top menu bar and click on File, Edit BMP. This puts me to the BMP screen. I select the second BMP, BMP2. I go again to the top menu bar and click on File, Edit BMP. You will notice that I get the message asking me recomputed discharge and volumes before saving. I click on OK. This opens the flow data and performance folders. I am not changing anything in the first folder. I click on Compute Discharge at the bottom right-hand corner. I move to the second folder, Performance. You will notice that the BMP type is dry swale and BMP design level is level 1. I now change the BMP design level to level 2 and click on Compute Treatment Volume. I go to the top menu bar and click on File, Save BMP. Update successful. I click on OK. As BMP2 is part of a treatment train, I now select the next BMP, BMP3. I repeat the steps to edit BMP3. File, Edit BMP and the flow data and performance folders are opened. I go to the pull-down list in the section, Volume, from Upstream RR Practice. I reselect BMP2, as I had revised this BMP. I click on Compute Discharge at the bottom right-hand corner. I move to the second folder, Performance. I click on Compute Treatment Volume. I go to the top menu bar and click on File, Save BMP. Update successful. I click on OK. I repeat the steps to open the HUC summary. You will now notice the remarks, satisfactory design, phosphorus load reduction exceeds target by 0.21 pounds per year. The File, Print command at the top will give a printout of the results of the HUC analysis in Excel format. Having satisfied that the required quality compliance is achieved, the next step is to design the BMPs themselves. The physical designs of all the structural and non-structural stormwater management facilities are discussed in the individual videos on each topic.